All right, I'm going to attempt to discuss one proportion confidence interval in this unit and also review critical value with you real quick. All right, let's see. Okay, take a look at this problem. You ask 1,000 people if they like steak. I guess not you, but if they like steak. If they like steak. Okay, and 350 people said yes. I want you to write an interval that you can be 90% sure that it will include the population proportion that likes steak. Okay. I guess before we start, I sort of want to go over one simple idea that we have talked about before, and hopefully you didn't forget. And I want to use this as a reminder of what you have to do here. All right, so KIS, all the male height average is 170. Standard deviation is 5. Standard deviation is 5. So this is all of the KIS male population. 170 is the average, which is a parameter, which is the truth. If you want to find a height interval that includes 95% of all male KIS population, how would you use the average to do so? Remember, 95% of the population is 2 standard deviations to the right and to the left. So this is what you would do. You would write 170 plus minus 2 standard deviations to the right and to the left. Then this interval, 160 to 180, will include 95% of the KIS population based off this height. That makes sense. And this is exactly what you were doing in this one proportional confidence interval. Okay, don't forget about this. I'll leave this on here so that we can discuss. All right, so 350 people out of 1,000 like steak. So the proportion that likes steak is 35%. And then this is p hat because this is a sample. This is not a parameter, right? This is just out of 1,000 people, and then this is what you found. It's not the true value. We don't know out of 7 billion people. We don't know the proportion of people that like steak. A god would know, but you are not a god, right? So all right. So 0.35 is your point estimate. That's your guess. That's your best guess. So now we need to do plus minus some kind of value. You can't just say 35%, so I guess plus minus 5 is good. No, this is actually created very specifically based off your data. And then there's a formula for it. And that's this value, right? That's this formula. It's literally just how many standard deviations away from your average guess. And then your average guess is 35%. So right now, the question is now saying that, okay, so the average, I guess, based on your guess, 35% is probably your best guess. And then you want to make sure that it has some interval so that it will include 95%. You want to be 90% sure. That also means that if you do this thing many times, if you do this thing many times, 90% of the time it will capture the truth. It means 2 things. So how do we do that? So how many standard deviations away is that? So we have to do. That's what we have to do. Now, hello. Okay, there you go. The standard deviation is easy to calculate. You have the formula square root 0.35 times 0.65 divided by 1,000. Remember, everything here is underneath the square root. You've done this before. It's also provided to you on the exam. So now we're left with how many standard deviations is plus minus 5 so that it will include 90% of the population. So now let's take a look at this blue part. You cannot just go to, oh, so we're going to include 90% of the population. So we go here. As you can see, 90% of the population, 90% of the population is right around here. So it's 1.285-ish, 90% of the population, right? 1.285. If on the exam you want to put 1.28 or 1.29, that's totally fine. As you can see that 1.285 and 1.28, the difference is so small that it won't make any difference when you calculate it. So let's just say, all right, 1.285. But 1.285 includes this entire shaded area. 1.285 includes this entire shaded area. But we don't want that. As you can see, we want to measure from the main center, I guess the average. We want to make sure that this space on the left and this space on the right are equally from the center, right? So what you need to do is actually 45% to the right and 45% to the left. 45% to the right, 45% to the left. Then that will include, do the plus minus thing. I mean, it will include 90% of the population. So if this is 45 to the right, that means that it leaves 5% over here. And then that leaves 5% to the left, right? So now, what do we actually, so you can't look at 90%. What you actually need to find is, you have to imagine that this is 45% to the right from the center. And then since the chart does not, the chart counts everything to the left, right? So what you need to do is you need to look at 45. You need to imagine everything is filled here. So this is 50. You actually need to look at 95% on the Z table. So that this Z-score will be 45% to the right of the center, from the center. And then if you do plus minus that, it will become 90%. You'll think it through. This is a very easy additional subtraction type of math. Okay, so let's say, let's find it. We want 95% because we want this right side to be 5%, so that if we do plus minus, the left will also leave 5%. So that will become a 90% confidence interval, means that 90% of the population will be captured in this gray area from the center. So 95. We want to go to 95. Where are you? Over here. 95, somewhere over here. So it's 1.645. Close enough. 1.645. So like I said, 1.645. So if you do 1.645, it will be 1.645 to the right of 0. So if you do plus minus, it will be 1.645 to the left and right. And then that will be your 90% confidence. It will include 90% of all of the guesses. Okay, that's it.